Ever wonder how a solar panel works? How it just sits there in the sun and poof, electricity? It feels like magic, doesn't it? But it's not. It's some seriously cool physics. And today, we're diving into the secret behind it all, the photoelectric effect.
So here's the big question, the real puzzle we're going to solve. How can a simple beam of light, something that feels like nothing, actually have enough force to knock an electron right off a piece of metal? Because let's be clear, getting those electrons moving, that flow, that's electricity. All right, to get our heads around this, we have to change the way we think about light. I mean, completely. Forget about light being this smooth, continuous wave, like ripples in a pond. Instead, you need to picture it as a stream, like a machine gun firing these tiny, individual packets of energy. And yeah, these little energy packets, they've got a name. We call them photons. You know, this whole idea was a huge deal, that light could be a particle. So a photon is just one little particle of light, and the energy it's packing is tied directly to its frequency. The formula? It's elegant, it's simple. E equals h times f.
So let's just break that down real quick. The E is the energy, right? That's the punch that one single photon delivers. The F is the light's frequency. You can kind of think of this as its color. And that H? Well, H is one of the universe's magic numbers. It's called Planck's constant.
And there it is. Just look at that number. Seriously, that's a decimal point with 33 zeros before you even get to the 663. It is ridiculously, mind-bogglingly small. And that's a huge clue, right? It tells us we were playing in a totally different ballpark here, a quantum world that just doesn't follow our everyday rules.
Okay, so if we're thinking of a photon as our tiny energy bullet, what's it shooting at? Well, the target is a metal surface, and that surface is just jam-packed with electrons, all just hanging out. So you'd think, okay, bullet hits electron, electron goes flying. Easy, right? Well, not quite. It's not that simple. See, the metal itself kind of holds on to its electrons. It puts up a fight. It's like there's a bouncer at the door, or maybe an entry fee you have to pay before an electron is allowed to leave the club.
And in physics, we call this entry fee the work function. It's the bare minimum energy a photon has to bring to the table just to get an electron off that particular metal. Every metal has a different one. And yep, it has its own formula, where that F naught is the minimum frequency, the threshold frequency, that'll even get the job started.
So what this means is that every single time a photon hits the metal, there's a showdown. It's photon energy versus the metal's work function, and it can only go one of three ways.
Okay, scenario 1. The photon's energy is less than the work function. It's like showing up to a concert with $10 for a $50 ticket. You're not getting in. Nothing happens. Scenario 2. The photon's energy is exactly the work function. The fee is paid, the electron gets